Hi guys. This is our first AP review session, and at the beginning of this section, I kind of talked about the different things that you need to do to be prepared for the test on May 22nd, and then I went into this problem. Well, there ended up being, and I think it's probably because I was trying to record and had lots of bandwidth with the actual live transmission of the WebEx, that there caused some issues. So I wanted to re-record this with just me on the desktop and talk to you through it. I think you'll have a better, clearer video explanation of the problem. So first of all, I'm going to be having you guys next week actually go through some questions that are the similar format we'll be using from the College Board website. So the ones I'm going to use today, tomorrow, and Friday are going to be ones that other people it's not on the College Board website have put out there. And so, you can take the types of, with a grain of salt. This is all speculation. Now, another speculation is the weighting of the points that you're going to have. First thing you need to know is that we've pretty much been told by the AP coordinator person that there will be more problems than more questions in a 25-minute setting for the first question and the 15-minute setting for the second question. There will be more problems than you'll probably be able to get to. Okay? So you need to not rush through it, but make sure that what you do complete is very accurate and thorough and includes all the information. Now, if you can't do one, then move on, okay? The reason for this is they don't want people to have downtime where they can then share and do all this kind of stuff. Everybody's competing against each other, trying to get as far as they can. So with that results, I'm just going to throw out some pure speculation to you about how this, there might be, say, 11 different parts to the first question you'll do for 25 minutes, and then 9 parts to a single question on the second question you'll do. And that's your 25 minutes and your 15 minutes, of which you probably won't get to all of those parts. Now, suppose that we say 1 point for each E and half a point for each P, then I would speculate, here's how many points you would have to get to be on track to get a 1 to a 5 in the final computing of your score. So I would say if you got 8 to 11 parts completed within points, then you're on track to get a 5. You've got a solid, no questions foundation of how to do this. Maybe 6 to 7 points are your 4. 5 points is going to get you at that 3. 3 to 4 points would be a 2, and 2 points and below, a 1. You have just a minimal understanding of statistics. All right, so let's go through this first question. I have 2 files here. One I've done the answers to, and then we'll start here with this blank one. So I sent this problem to you in Gmail, and so this first one is talking about our letter E. We're talking about the letter E that appears in the words of the English language. And there's a claim that it appears in 11% of all words in the English language. However, a curious stats student is suspicious that textbooks are different. Okay? After all, academic textbooks are not known for being readable. He takes a random sample of 200 words from one of his history textbooks. So it's important to think about, where is his sample coming from? And this gets into experimental design, Unit 3. And the reason that this gets into experimental design is because you have to think, who does he have the right to generalize to? When he makes a statement, is he going to generalize to all words in the English language? Is he going to generalize to all textbooks? Or is he going to be able to generalize to his history textbook? So you need to consider that. And we'll talk about that in a second. So his sample results that he gets out of his random sample of 230 out of 200 words contained an E. That's 15%. So it's a little different from 11%. How different? Is that a big difference, a little difference? What does it mean? We'll have to do standard deviation and all that kind of stuff. So the first question here is, name the procedure that the student could use to examine if his entire history book, so that question is kind of stating to us who he's going to be generalizing to. And I think that's the correct population who he'll be able to generalize to, because his sample is of his history book, which might be very different than our statistics book or an English book, a literature book. You got all your Shakespeare and stuff, all those different things. Anyway, so he wants to see if it's different than the reported proportion. So we're obviously dealing with proportions here. So what procedure would we do for this inference to see if there is a difference than the claimed proportion? So we did that the first week of distance learning. Is he making an interval, or is he going to be doing a test? And so when we did the live class, someone said class or test. Okay, so we're doing a test. And so now, okay, it's a test, not an interval. Okay, is it proportion or mean? Okay, so I think we can see it's proportion. All right, is it one proportion or two proportions? Okay, so here is where I probably was saying that incorrectly, and it led to the wrong answer from the group. The group said two proportions. Well, my question should have been, was it one sample results or two separate samples? Did we get a sample from a regular drama novel or whatever, and then a sample from a textbook and have two separate samples? That would be a two proportion z-test. No, we have this is the population claim, and we have one sample result of that 30 out of 200. So we have, as a result, a one proportion z-test. Okay? Remember that proportions are always z's. Means are most always t's. Okay, and the reason they're t's is because you typically only have the sample standard deviation. That's for means. All right. So does it say to explain why? It doesn't. Now, here's the next question, and I really disagree with how this teacher wrote this, because all this question really says is write the appropriate hypotheses that would be used to carry out this procedure. So, okay, let's think of a test. Is that a panic or a phantoms? Okay, so hopefully you know that that's a phantoms. A panic is a confidence interval, your conclusion to your interval. Okay, and so name the interval. Phantoms is a test. All right, so let's see. So we want to do the hypotheses. That's the H. So that we know our null hypothesis is the claim that P equals 0.11. The alternative hypothesis is, colon. Okay, so the null alternative hypothesis is P is what? And it's seeing if it is different. Okay, so that's a not equal to. So this is going to be a two-tailed. And we're seeing if it is different than 0.11. All right, now, a couple things. Notice, of course, these are always population P's. Don't put P hats here. Okay. But the other problem I had was it should feel very naked to you to write down this letter without having done the P part of the phantoms, defining the parameter. What is this P standing for? So, in fact, in this teacher's grading guidelines, he had written what the parameter was. And I was like, okay, well, then you should have said that. So he didn't write down what the parameter was, but I guess he just assumed that we were supposed to know that we were supposed to include that in addition to the hypotheses. So you need to define the parameter, P. What are we inferring? And we are going to infer, it's a proportion problem, we are going to infer about the proportion of, we're going to make a claim about the proportion of what? All books, all textbooks, or his history textbook. And we've already talked about that. The population we have the right to generalize to is his history book. So let's take a look at how I wrote that. So here we have the proportion of English words that contain the letter E in his history textbook. Okay? So make sure you do that, and then there's your HO and your HA. Now, let's go ahead and take a look at this next question. This next question is one that I think you might have gotten the general gist of it, but there was actually a very specific thing that was needed to be included to get a full point instead of just a half a point. So let's talk about that. So this says 11% of the proportion was exactly true for this random sample of 200. Then you would expect, the expected value is going to be about 22 words that will be with, 22 with the letter E, and 178 without. So describe what's the importance of those two numbers, and what conditions are they verifying for this procedure? So I hope that you are able to connect that this is a problem where we're having at least 10 successes and at least 10 failures. And what part of our assumptions is that referencing? At least 10 successes and at least 10 failures? Well, that's referencing the large enough. And our conclusion for that large enough is to say that we have an approximately normal distribution. So saying that gets you half a point. And here's why. Here's why that is incomplete. So let me insert in a little page here so I can draw you a picture. So here's what's happening. This is a proportion problem, so it's binomial. I mean, here's the here's the population. The ones that's probably the ones without the letter E, and here's the ones with the letter E, or whatever size those are. Remember, it's categorical data. So with and without. Okay? We're not talking about the population being approximately normal. That's just 2 bars. That's categorical. I could even draw those in whichever order I wanted. We're talking about this drop-down samples. I'm going to randomly select 200 of those items and see where that proportion results. I'm going to randomly select 200 of those things and see what proportion of those words have the letter E, and so on. And because we have at least 10 successes and at least 10 failures, this is a large enough sample that we expect the result of all of these samples to be approximately normal. Okay? So this is really a Unit 5 idea that they wanted completely communicated because it shows that you have a full understanding of the statistics. So what this is saying is something very, very important. I'm going to type it out here. It says that it's large enough. This item down here is the distribution of the samples. Okay, so if we've got this thing here that is the distribution of samples, then what we have is, what is that called? When we have this, not the population, but the distribution of samples has a specific name, and you have to say it by name to get an E instead of a P. This is a sampling distribution of samples of size 200. Every single one of those P hats came from N being 200. So, full credit for that particular problem had to say something such as this. There needs to be at least 10 successes and at least 10 failures so that the sampling distribution, and that's what I highlighted, of samples of size 200 is distributed approximately normally. My students wanted to say it needs to be at least 10 successes and 10 failures so that it will be approximately normally. It, bad, bad, bad. It is too generic. You're not saying what it is. The population doesn't have a shape. What are you talking about? Okay. So anyway, I just want you guys to bump up from a P to an E. Now, the next question says, the p-value for that problem. So see, here's where they might not have you actually do a lot of computing, but yet interpreting. The p-value for this procedure is calculated to be 0.071. So they did all the math and they said p-value 0.071. Write the appropriate conclusion for this procedure. So you need to think, what is the next part that we would be doing in after our p-value? We would get our p-value in our phantoms. What would we do then? We would obtain a p-value and use a significance level of 0.05. We would compare to alpha. So I'm going to use that p-value, compare it to alpha, make a decision, and then state my conclusion. OMS of the phantoms. So here we go. So here's our obtain a p-value. P-value of 0.071 is greater than alpha of 0.05. What are you going to do if the p-value is greater? I'm going to fail to reject HO. So if I fail to reject it, then after I say I fail to reject, then our next sentence is about evidence or no evidence of HA, and put your context in. Evidence or no evidence of HA. So there is not evidence to suggest that the proportion of words in his history book, again, there is the population I'm generalizing to, that contains the letter E is different. It was two-tailed. Okay. Now, look at what this question says. Also interpret the p-value in context. Okay? So, with that, I want to do a quick review on p-value. So, if we've got this p-value, then we've got this situation. So, let me kind of draw for you what's happening here. Okay, so we've got this is the sampling distribution, okay, and we know that our sampling distribution is centered at a proportion of 11%. So most of our samples are going to be around 11%, okay, but the sample results we got, the p-hat we got was 30 out of 200. Well, that's 15%, okay, so the sample results we got was about right here. 0.15. All right, now keep in mind this was two-tailed. Okay, so an two-tailed means that alpha of 0.05 is split between the two tails. So here's the rejection region. So here is half of alpha. We got the upper 2.5, and then because this was a two-tailed, so this is the bottom half of the alpha. So we have the bottom 0.025, okay? But anyway, so we double those p-values. I'm going to just kind of demonstrate this and think it's easier to do it thinking it as just one-tailed, even though what you do for two-tailed, remember, you would say, ooh, how much area is this? And I need to times it by 2 to account for the two tails. All right, but let me jump back and let's pretend just for simplicity's sake that we're just talking about one side. I think that makes it kind of easier to wrap your brain around. Pretend like this is the size of the rejection region and all 5% is right there, and our sample results were here, and our p-value, this blue area, is 0.071. So the question then is, what is the definition of p-value? What is it saying? And so remember, brown-eyed girl, the p-value is the probability dun, 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 of getting this sample or something more extreme if the null is true. Okay, so this p-value, there's a 7.1% chance the p-value is the probability. There's a 7.1% chance of getting this sample results we got, 30 out of 200, or more extreme, or something more extreme, if all the samples are really, if the population, if all the words in his history book, 11% of them have a letter E in it. context understanding of what p-value means. P-value is the probability of getting the sample you got if the claim is true. So here's how I wrote it, and I actually wrote it wrong. I put a wrong number in here. There's a 7.1% chance of getting these results of 30 out of 200 or more extreme results if p equals 0.11. Now, I probably could have done a better job there and put even some more context. 7.1% chance of getting these 30 out of 200 words with the letter E in his textbook if, in fact, there's 11% words with the letter E in his textbook. So I think I could have done better context on that answer. But I'm just going to give myself a little leeway because I had kind of defined what P equals and such earlier. Anyway, all right, next. Okie dokie. So where are we? We're, I think, on problem E. So we've done 4 complete parts, and here comes our next one. So our next one is, if an error was made in this procedure, would it have been type 1 or type 2? Okay, so now here we got to think errors. It's not asking us power. And describe a consequence. Okay. So my first thought is I need to wrap my head around the definitions. Okay, and I'm making a little shortcut sheet, and it would have that on there. Okay, but here's what I'm thinking. If in my brain, I'm thinking, okay, type 1. Okay, so let's see. What is type 1 error? That means HO is really true. HO is really true, but we made a mistake, so we shouldn't have rejected it. Hey, girl, I shouldn't have rejected you, but we reject. Okay. Is that what we did with this problem? With this problem, we actually failed to reject. Our p-value is large. We did not reject. Okay. So therefore, I don't think I'm dealing with type 1 error because we didn't reject with this problem. So therefore, we must be dealing with a type 2 error. Okay, so I'm actually just going to type in here. I think that would be easier. So we're dealing with type 2. Let's make this a little smaller. So we're going to deal with the type 2 error. Okay, and so let's see here. If I can do that, we got type 2 error. Type 2 error. Okay, so let's think. Why is that considered a type 2 error? Well, okay, so let me think. Type 2 error, we failed to reject a false null hypothesis. So we did not reject. Okay, so here's me thinking just in terms of like, I just got to kind of talk it out in my head. So I need to eventually get context. But right here, right now, I'm just kind of thinking through this in my head. Let me maybe type up here some notes for myself. That type 2 error, I failed to reject HO, but I should have rejected it because HA is really true. Okay, do you remember our mean? Why reject the null? Okay, maybe I ought to put those means on our shortcut sheet. Why reject the null? Okay, I failed to reject the null, but I should have rejected it because it really does have different than 11%. So now get context in here. Context. There really is different than 11%. Whatever this is called. Okay, so there really is different than 11% words with an E, with the letter E in his history textbook. Okay, see, there's the context. I should have rejected HO but I failed. I did not have evidence to do so, to reject. Okay. All right. So I actually had it written up this way when I did this myself in handwriting. Okay. So I kind of just jimmer jammered around here. Here's kind of a picture, of what was happening. So up here in this corner, see, 11% is the null. I had a p-value that was not in the rejection region. Okay, and through that one-tailed test, that was wrong. But anyway, so in this case, we do not have evidence that the proportion of words with E is different than 11%, and so we should have rejected it. So my problem I had, describe a consequence of this error. So I hope that if this was a real problem, then they would have given us something like really important, like somebody's losing money, or it's hurting somebody's health, or it's hurting the environment, or something like this. I'm like, okay, boo-hoo, it's not 11% letter words with the letter E. I mean, is this going to kill somebody? Okay. So what I wrote was this. This is kind of interesting how I pulled this. I was like, I don't know. What kind of consequence are you wanting? So I put the consequence, I don't know. The consequence may be we have a wrong conclusion about the reading level. I don't know. We are definitely drawing a wrong conclusion. I didn't know what a killer kind of a consequence we would have. But do make sure that you type your consequence, consequence in context, okay? All right. So there is another problem. Fifth one down, 5 out of 11 points. All right. Next. So the student had access to some software. So the student decides to run a simulation. So they took random samples of 200 words, and they set the little parameter in the software at 11% of the words containing the letter E. So here's what this ended up looking. So below are the results of running the simulation 100 times. So let me tell you what that means. There are 100 dots here. And each one of these dots is a sample of 200 words, randomly selected words from his history book. And the number of them, see, these are the number that have letter E, number of words that have letter E. Okay? I don't know why this has two pictures. I know I ended up drawing over both of them because a lot of these problems use the picture, so may help just to have those two pictures because of that. But anyway, so let's kind of talk about this. All right. So the next question is going to ask you to describe the distribution for that simulation. So automatically describe the distribution. Describe the distribution, shape and outlier, center and spread. So shape, outlier, center, and spread. Describe that distribution, okay? So I need to go and address those items. So let's go back. So what shape would you say about that? So I'd probably say it's unimodal. Maybe slightly skewed right, but somewhat symmetric. I mean, real-world data is not going to be perfect. So I defined it as unimodal, somewhat symmetric. Okay? I don't think that's enough to say, whoa, that's skewed. All right, so I'll put that down in a minute. Next, outliers. Okay. So outliers. Okay, so if we've got unimodal and symmetric, then that plays into which measures of center and spread and outlier rule we're going to use. So if we're unimodal and somewhat symmetric, what should we be using? Median and IQR or mean and standard deviation? And I could argue for using mean and standard deviation. If you have skew, then that's when you would choose to use median and IQR. Ooh, symmetry, standard deviation, and mean. Okay, so I want to figure out what is the standard deviation and the mean for the number of words. So I need to figure out, okay, what's the mean? The mean number of words and the standard deviation for the number of words out of 200. So what's the expected value? Well, looky here, formula chart. I think the mean kind of makes intuitive sense. So if we take a look at this section here where binomial, and I had a student ask me in the session tonight, how did I know it was binomial? Well, a couple of reasons. One, this said binomial. Okay. Two, the other reason I knew it was binomial is because these were discrete amounts. 15 words, 16 words, 17 words, a whole number amount of words. Not like 18.3 words or 19.7 words or 16.85379. That's continuous. This is a discrete random variable. So when we look at this formula chart, then what we're saying is the mean is how many I expect, the expected value, and this standard deviation. So I've got this formula for the mean and for the standard deviation that I'm going to use. And so in this case, the mean, n is 200, with the proportion being 11. So that comes out to the mean should be 22. Okay? And then I'm going to do this standard deviation by filling in those numbers there. I got the square root of 200 times 0.11 times 0.89. And that comes out to be 4.42. Okay? So I've got that written here in this picture over here to the side. Okay? So I've got this mean and this standard deviation using those formulas. Okay? So that's what I'm going to put for my center and my spread. And I'm going to be specific and I'm going to state that it's the mean and the standard deviation. But now let's go ahead and talk outliers. What's our outlier rule for mean and standard deviation? And that's mean plus 2 standard deviations up, mean minus 2 standard deviations down. So here we go. So I took the mean, added 4.2, added another 4.2, and that's the upper fence of 30.84. So therefore, look at these samples. There were 1, 2, 3, 4, 5 samples that were upper outliers. Okay? Lower fence. Here's the mean of 22. I'm going to subtract 4.42 and then subtract again, and I get 13.16. That's my lower fence. So I get one lower sample was an outlier. So therefore, in conclusion, my socks is like this. Here's my calculations again up here at the top, FYI. So I went ahead and I had transferred it over, but you didn't have to, because they would take other notes that you have written around there, okay? Shape of the context. Shape for the number of E's, the number of words, I should say, the number of words that contain the letter E is unimodal and somewhat symmetric. Outliers are 5 samples above 30.8, 4 and 1 sample below 13 point whatever that 16. The center is be specific. It is a mean of 22. The spread is a standard deviation of 4.42. Okay. Now, I had one student in tonight's WebEx say she interpreted it as it being a little skewed right. It was slightly skewed. So I really don't think that was your best choice, because real data is not going to be perfect. But she did use that. And so she used median, and it was 22, and she used IQR, which actually ends up being the last part of this problem, and she showed how she calculated. She got 6. So again, see there, but she justified the fact that she used the median and IQR because, and she had then different outlier fences, because she used Q3 plus 1.5 IQRs for the upper fence, Q1 minus 1.5 IQRs for the lower fence. So she justified that by saying, I think it's a little skewed right, so I'm going to use the median and IQR. And that's good. All right, next. Without performing the calculations, which you could have done, but they wanted you to justify it because here in Unit 1, one of the keys to Unit 1 was the fact that you recognized the connection between the measures of center and their shape. And remember where that comes from. And I have a shortcut sheet that I'll reference as we go through some things. I'm still working on it, but I'll get that to you. Remember our little thing where we would say mean, median, mode? And if they were somewhat symmetric, then those are about the same. Okay? So because of the somewhat symmetric, the mean and the median will be similar. I didn't know if they were exactly the same or not. But I was actually a little worried. The fact that I had 5 upper outliers and only 1 lower outliers kind of like worried me a little bit for the same reason that other student in my WebEx kind of wanted to lean towards it being skewed. So I made this note here. I said, however, there are 4 more upper outliers than lower outliers. So it is possible that the mean is a little greater than the median. Because remember, if you have the shape of the distribution like this, if it was a right skewed, then you would point to the right. And so that would say those things are a little bit in that relationship there, mean a little more than the median. Okay. But they wanted, that problem was, do you know the connection between shape and the measures of center? All right, and they wanted you to reference the symmetry or skew. Okay? All right. Next problem asked you about how you can, why is it appropriate that it is a binomial distribution? Okay? And I'm going to have to be honest with you. I think this one that I, as a teacher, was not consistently talking to you about this throughout this year. Okay, so this would have been, I would have noticed that when my data came back that my students would have tanked on this one here, and my students would have not known the criteria for being binomial. Okay, and the fact that one of my WebEx students asked me earlier, how did I know that it was binomial, is telling me as a teacher, I probably should have stressed that more. But let's go ahead and have a little mini session of learning. When I first introduced our binomial situations, it's because we have bins. We have, and here it is over here. So I'm going to go ahead and put this on our little shortcut sheet of notes. So by in the bins is referencing it's binomial. It's by 2 choices. You either have success or failure. And we have that here. We have the words has an E or it doesn't have an E. 2 choices. Binomial. Okay, and independent. The words are selected independently of each other. Okay? The other criteria for in, and I've said this, as opposed to geometric, we go until a success, but binomial is for a set number of trials that you go and you look at, and we were looking at a set number of 200 words, and then checking the proportion of those. And that each of the words has the same probability of having a letter E. I know that kind of ties into our ideas of the independence, independently selected, same probability. All right, so there's that. So that is the criteria for actual defining that binomial. So I'll add that to our little notes. Now, okay, so here we are to our 8th point available to us. Or maybe 7th. This is one problem that is going to kind of be a new idea to you right now. But every year when I do the AP Review Crunch at the end, this is a concept that I show multiple times. And I hope to do that over the next week and a half. And I show multiple times. So this may be a little new to you right now, but hopefully when we do several problems, you'll start to see this creep in. So this problem says, how do the results, let me get to the one with the clean picture on it. How do the results of this simulation, so we're going to have to reference this picture, compare to the p-value provided in part D? Explain. All right, so let's first remember, make a little note. Our p-value in part D was, oh, I don't like to write p equals. Bad. Okay, our p-value, because that's different than p equals. That's proportion. Okay, so our p-value, the probability of getting the sample results we got or more extreme was 0.071. Okay, so we want to see how close was our physical simulation to this. Did we have about 7.1% of our 100 dots in that simulation that were at that same location or more extreme than the sample we got? So let's see. Let's take a look at one of these pictures. Okay, so I'm going to zoom in on this so we can kind of look at it. Okay, so let's remember that the p-hat, our sample results were 30 out of 200, okay? So that was our 15%, We had a sample of 30. Our x was 30 out of the 200, okay? And then our mean out of the 200 was 22. It's 11% of 200. Our standard deviation for that 200 was 4.42. Okay? All right. So, because we're talking about the number of items, not this proportion of items. So I'm really going to kind of focus on these things. So the question is, how many of these dots were this or more extreme? Well, let's see. Okay, so I get that. I see that's 1, 2, 3, 4, 5, 6, 7. Okay. Problem, however, do you remember that our p-value came from a two-tailed? So I cannot just look at those ones right there. I've got to figure out what's the flip side. That's what kind of made this problem trickier. If all it was a one-tailed, that would be very easy to see. And honestly, on APFRQs that I've seen, they've been one-tailed. Okay, but we're adding this level of difficulty here. Let's just see. So, I gotta see, dang, what is that location right there? So I can do the same location over here on the left and see how many of my samples are over there. Is it this or is it this? Where is that located? Okay, so what I have to do really is I gotta figure out, dang, how far is this away? What's its z-score? So guess what? That z-score is x minus the mean over the standard deviation. So lo and behold, this cutoff was 1.8 standard deviations above the mean. Well, you know what? Let's go down 1.8 standard deviations. Here's 22. 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a little more than a half. Okay, so whatever that comes out to be, I think it's 14 point something. Boom, right there. There is symmetry of our cutoffs. 30 is located 1.8 above the mean. This is 1.8 standard deviations below the mean, so I can see, got that right there. For a total of how many simulated pieces of data, samples, how many simulated samples were in my p-value? The probability of getting those sample results or more extreme, 8%. 8 samples out of 100. So simulated was a p-value of 8%. Well, how'd that compare to the theoretical, what this said? There you go. So the simulated results, and I would have to write that out. And actually, here I have it here. They are pretty close. The simulated p-value of 0.08 is represented by the 8 out of 100 samples that are at plus and minus 1.8 standard deviations away from the mean. So there was me writing it out. I actually had drawn it on my picture here. See, here's this, here's this. See, simulated p-value. So I had actually done some work on my picture But this was me writing it in words. So that simulated p-value of 0.08 was pretty close to that theoretical p-value of 0.071. Okay? All right. That was question number 8. That's pretty stout. Again, I've only seen those in APFRQs like one-tailed, so that added a level of difficulty going in both directions. Next, the next question says, hey, based on the results of the simulation, again, using the results of our simulation, okay? So based on the results of the simulation, how many words would you need to see in a sample of 200 with the letter E to convince you that the book has fewer letter E words than 11%? Fewer. That's a different statement than different. What does this change about our hypothesis statements? Fewer than. Well, that null hypothesis will still be 0.11, but our HA will be P is less than 0.11. Okay? And so we need to see, okay, in my simulation, where would I have, remember we're going to use our same alpha, so what I need the rejection region of 0.05 to all be down here. So the question then is, what is the number right here? You know, how far down does that have to be so that it is in the rejection region in the lower 5%? So, I need to know what that z-score is. Oh, and forget, I'm talking number of items, not proportion. This was 22. Okay, and then of course our standard deviation, if you remember, our mean of the number of items was 22. Our standard deviation for the number of items was 4.42. It's interesting that this problem all dealt with number of items instead of using all p-hat stuff. So it was all about the number of items. Hence, that's why we were using these formulas here, because these were talking to me about the number of items. It's interesting, as opposed to if you were doing, if they were just asking about the proportion of items being centered at a proportion of 0.11 with this proportion standard deviation. See? So this is a units thing. We were doing everything in terms of the number of items instead of the proportion of items. So, interesting to bring that up. So, where is this? Okay, I need to find out what the z-score is at the bottom 5%. Inverse norm of the area below is the z at that spot, and it's negative 1.645. And so that's what I'm going to do to solve, and I have that written out here. So let me just go ahead and show you that. Let's do it. So here is my picture. There on the left, bottom rejection region. Here's x minus mean over standard deviation. Here, this is right here. So I solved for x and I got 14.7. So be careful in your wording. There would need to be less than 14.7 words, but this is discrete data. So I bet you they would have required you saying 14 words or less. Okay, this probably right here would not have been ideal because this is discrete. Okay, that contained the letter E to reject P equals 11 for P is less than 0.11. P equals 0.11, okay? All right, there we go. That's the 10th item. So now here comes the last one on this monstrosity of a problem. So, and you know what? It was actually pretty simple, I think, compared to some of the problems 8, 9, and 10, the 8th, 9th, and 10th question. This 11th one is a little easier. So don't get hung up. If you're struggling, don't think they're always going to get harder. Go on, if you're sitting in the last 5-10 minutes and feel stuck, go read ahead. Explain how you could use this simulation to estimate the IQR. Well, you're going to have to do that by hand, so let's see how that's going to work. Let's recall that if you've got 100 pieces of data, that median is going to be right there between the bottom 50 and the top 50, okay? 50-50. Then you need to do this. You need to find Q1 and Q3 because IQR is Q3 minus Q1, okay? So I need to get the middle of the bottom half. So that's split into the bottom 25 and 25. So there's my Q1. And then I need to find the middle of the top half, 25 and 25. So I actually went over here to my dot plots and I physically counted this. Okay, so see, I counted the bottom 25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on and so forth. And there it was in between the 25th and 26th one was right there. So that Q1 is 19. And then I counted down from the top 25%. And I think it was in here somewhere. So that Q3 was there at a value of 25. So therefore, I wrote it here that my Q1 was 19 and my Q3 was 25. And then I think I went on over here and wrote that out. According to my simulation, Q1 is 19 words and the Q3 is 25 words. So that makes simulation 6 words. Context, context. I'd hate for them to mark off because you weren't always tying it back to the context of this problem. Okay. All right, guys. So that is a huge problem. That would have you just had 25 minutes to process all of that, and I just would be so surprised. I'm pretty sure it took me longer, because I was trying to write it all in and be thorough and think about how am I going to teach it. But I think I spent more than 25 minutes on all of those 11 parts. So don't be intimidated if you don't get to everything. Stay calm and do whatever you can do in the best quality that you can do it to make sure you're getting as many points as you can. Okay? So thank you so much for this first problem that we are going through for our AP review. I will see you tomorrow and we'll do the second problem, which is smaller. It's only a 15-minute question on this practice exam.